here is the graph that I'm super excited about today. And it compares the mean years in school of women ages 25 and older. So that means for each country, the average number of years that the women who are 25 and older have spent in school, compared to on the y-axis is the life expectancy for women of that country, so how long we expect them to live. The two other variables that we're looking at here are the size of the bubbles is the population of the country, and the color of the bubbles is by their income level. So darker bubbles have lower income in that country, and then lighter bubbles have higher income. So to analyze this data, I drew a line of best fit, and you can see that I drew that here in green. And to figure out my rate of change of my line of best fit, I drew a blue slope triangle. And I saw that for every 6 extra mean years in school for women, they gained 13 years in the life expectancy of that country. So when I think about that, that rate of change is either 13 per 6, or if I simplify it, 2.2 per 1, which means that for every 1 year in school more that a country has on average, about 2.2 years of life expectancy is added for that country for their women. Now, the initial value, it's a little weird because the 0 line is right here. It's not in the corner like it usually is. So the initial value right here is 0.57, which means that if a country had a mean years of school of 0 for women, then their life expectancy for women would be 57 years. This makes our final equation of a line y equals 2.2x plus 57, which we will use later. When I look at this association, it seems like positive association to me. I see this graph slightly going up like this. And it also seems like linear association to me because I can draw a line that best approximates that data. It seems like moderate association because the points aren't like smack right on the line. They're all over the place, but they're definitely like going up in a moderate linear way. When I try and use that data, I can use my line of best fit, and then I can make guesses about if I know a country's mean years in school for women and I know a country's life expectancy, I can figure out one or the other. For example, I picked the number 3 for mean years in school right here, and then I calculated by looking at the graph that a country that has a mean years of school for women, which is 3 years, will have possibly a life expectancy of 63.6 years. I also used the equation to figure out an extrapolation or a number that's beyond the graph for 20 years of average years in school. And I found out that the life expectancy for that, based on my graph, would be 101 years, which seemed a little far-fetched. So I feel like there must be lurking variables that go beyond just the graph here. So let's talk about what this data kind of means. So I found Panama and the United States in this data. You can see Panama's a tiny country here, United States is a bigger country over here. And when I look at Panama's point, its point is 9.2, 78.8. So this means that in 2005 at least, Panama had an average number of years of women going to school of 9.2. And the average life expectancy for women was 78.8, or nearly 79 years old. And that is slightly above my line of best fit, which means that Panama is doing better than my predicted value, better than expected according to my model. And Panama has, it looks like, kind of a greenish income level, so kind of mid, because they at that point had an income level of $11,900. Now the United States, this point right here is 13.580, so they had kind of a much higher average number of years for women going to school, but their life expectancy isn't that much higher. And look, the United States is below the line of best fit, so that kind of makes me wonder what's going on in the United States, what other variables are happening here that's making it so that the life expectancy for women is lower. Conclusions that I can make in general, while I believe that the data has association, meaning that I do believe that there's a connection between how many years in school on average that women can go to school versus life expectancy, I don't believe it's causation. I don't think that if you increase the number of years that women go to school, you're automatically going to increase the life expectancy of women, because that doesn't necessarily make sense to me. There must be other lurking variables here. So when I think about lurking variables, I love Gapminder because you can see them. For example, look at the colors on this graph. All the darker colors are over here on the bottom left. Most of these are lighter colors up here. So income must be a really big lurking variable here that actually affects the way that affects people's life expectancy, possibly even more. And when I connect how many years in school women are able to go to school, when I connect that, it seems like that might be connected to income even more than it's connected to life expectancy. Because I know that I've been able to live in countries where women are allowed to go to school, and I've been fortunate enough to myself go to school for a lot of years, and that really only exists in certain countries. So what might this data mean for the world? That might mean that the world should take steps to improve both income level, to make it more equitable, and also make sure that people have access to schooling, and that possibly life expectancy may rise as we work on those issues. Someone might misuse or misinterpret this data by thinking that women from poor countries are lazy because they should just go to school more and then they can live longer. But since we know that association does not imply causation, there's a lot of factors here that we need to consider. So there's a lot going on with this graph and a lot more that we could possibly learn, but I think that we can pull a lot out of it.